Hey everyone, my name is Johannes, and today I'm going to show you the study I did of a cheetah running. So let me show you the final result first. So the idea was pretty simple. I wanted to make 3 sculptures of a cheetah and line them up one after the other in a cycle so that it creates this idea of a cheetah running. This ended up getting pretty tricky. In the best scenario, I would have done 4 frames. Now this was 3, because you always have those 2 extremes. So you have the maximum extended pose and the minimum scrunch one, and then you would have the other one again. So that means that I would need 2 in-betweens and not 1. So I was kind of always stuck in between the 2, but that's how I separated it. I made this one, this was my first extreme, and then the other max poses, and then the other one in the middle. So as soon as you would have a rotation, I needed to have this sort of triangle. So if you look at, for example, the head, you're gonna see that it goes forward, back down, and then up, back, and then this constant triangle. We have circular motion. Now the same thing goes for the hips. If I take a look at the hips, we have this first pose is going to be up, and then now it's extended like this, and then once I'm going to have the scrunch position, it's going to be angled all the way to the back. So the way a cheetah moves is when he brings those legs forward, this is where all the flexibility of the spine comes in and lets him put those legs so far forward. So you're gonna see in the next position, this is artistic, so it is very extreme, but the leg can extend very far forward like this because the hips are rotated, and so he can plant that foot way forward and then keep his leg straight to push him forward. So if we look at the anatomy of a cheetah, so this is a simple cat, this is also a simple cat, but if you look at the cheetah, you're gonna see that naturally when they pose, they have, all of the legs are cut in this one. Okay, this is pretty bad, but you're gonna see that I'm gonna take this one. So their legs, they're very straight angled. This line is almost perpendicular to the ground. So what this means is that when they plant that step and they start pushing with their foot over here at this position, because at first he's pulling with the front, and then at the end it's the tip that's pulling over here. So what's the muscles that are gonna cause that pull? If we look right behind, we're gonna see we have these massive muscles here, and we have, so these muscles here are gonna pull the knee backward, and then these over here, your calf muscle, they're the one that are gonna pull on the foot, and the ones in the front help to get that planting on the ground. So since we have those leading up, they're gonna pull like this, our hinge by increasing here, and then this is gonna pull on the ground to go backward, and the angle that we get of the foot that is straight pulls the cheetah right away forward since the angle is straight. If we look at another cat, for example, a lion, he's a pretty good runner, but if you look at the angle of the foot, you're gonna notice that naturally, first of all, it's way shorter, and second of all, the angle is way more angled backward. While the cheetah was almost straight, this one is angled backward. So naturally when he's gonna push, it's gonna push him upwards a bit. So you're losing a bit of energy just in your anatomy, in the way it's built. So these are the type of information that I was trying to get in my study. So I broke it down in 4 different sections: the flows, the shape, the volume, and the movement. These are 5 dimensions if you want. You have the flows, so a straight line or a curved line, and then you can add acceleration in that line. So you can have quick and then slow, or slow and then quick. So that's your flow. So it's kind of 2 dimensions, but let's say it's 1. Then you have the shape, which is an assembly of flows that you put together. It creates an area, and we have a flow in our shape, since they have certain angles, they have direction, so you can lead with these you could call them rhythms. You have rhythms in your anatomy that helps to propel forward. You're gonna start to see some lines and why they're efficient. So that is shape. And then volume is building that 3rd dimension, getting the depth and seeing how that influences the movement. We can start to have flows in 3 dimensions. So and then movement. So while before I would build flow as the base, and you need flows to build a shape, and then you need flows and shape to build a volume, movement directly impacts the flows. Talking about these flows in the anatomy, I'm referencing to certain angles that the muscles have together, and how that influences the behavior, the locomotion, the stance, how it modifies the structure of the animal. So right now in this representation of the cat, we have the hips almost pointing straight down, and we have the angle of the foot matching this. This is pretty typical. You're going to have the same angle between these 2 joints and the same angle between the hips and the legs. Cats don't have that much motion. So let's say when you take the difference between the length of the back muscle of the leg and the front muscle, you're going to see that one is almost twice the length of the other. So what that means is that this muscle here is pulling around this area. So when he's going to pull, he's actually going to start pulling the leg forward. These muscles, they have a very small attachment point, so it's harder for them to pull, right? They don't have a lot of leverage. If you compare that to the ones in the back, these are attaching right now all the way to the middle of the other bone. When you look at human anatomy, that muscle would be somewhere like here. What does that change? Well, if you have it forward here, as a muscle, right, it only contracts a certain amount. So if let's say it contracts half its length, it's gonna hit somewhere like here. Okay, this is half this length, and then the bone, he's gonna go over here. If you took a human and you put it twice the way back here, then it would go up like this. So you get more movement. The closest it is to the joint, you get more range, but you get less strength. So we can see here that the animal, the cat in question, is putting a lot of emphasis in his anatomy on these muscles, on pulling backwards. In the front, for pulling in this direction, not so much. So this is our first joint, and it tells us that it is stronger to pull backwards. If we go in this direction, this is pretty interesting. So we have the joint of the back here, and we have our final joint we're going to consider today is all the fingers as a whole. So if we look at that joint, and we pull with our friendly calf muscle over here. I would be interested to see where it is actually attached, because when I was doing my research, I felt like they were actually very high. They would pull pretty high. So I would expect a lot of strength from this. Maybe this is a smaller cat, and so it is a bit lower, but I feel that the cheetah would actually, I would expect something like this, because I'm seeing the curve, the natural curve of the cheetah that we're getting over here, and I would expect something like this. So you get a lot of force holding back, and then the paws over here have these long muscles that are pulling in the back. Why? Because if you take the fingers, they're just like this, just like the knee. So when they're pulling up on a very thin membrane. They don't have a lot to hold on to. So the best strength that they can get is in being very long and fibrous, so that when they pull on longer. So they reduce the length even more. They need less strength. So then I started playing with a lot more stretching. Here everything was scrunch, so you have big volumes. Over here, scrunch, 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 and then tension over here. In the other one, we have tension, 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 tension. And then the only scrunch, no, not even. I tense the neck. I tried to tense everything. So this was a quick recollection of my thoughts after this study. It was a bit messy, but I hope it was somewhat useful. And until next time, goodbye, people.